Snell's law in the vector form. Okay, so what is the Snell's law in the vector form? Let's say that there is a boundary over here which separates two media, which is nothing but mu1 and mu2, right? And over here there is an incident ray in this direction, right? And therefore let this be the refracted ray. This is in the other media over here. Now in the vector form, the Snell's law goes like this: mu1 into a cap is nothing but the incident unit vector cross product with n cap is equal to mu2 times the refracted unit vector is nothing but r cap cross product with n cap. What is this quantity called as n cap? It is the unit vector which is normal to the boundary, and it points from the first media into the second media. This is your n cap. Now on solving this, what are we going to get? We will be getting two values of the coefficients of r cap. So the another property that we'll use for the unit vector is that the magnitude of the unit vector is nothing but equal to 1, which is equal to root of rx square plus ry square plus rz square. On making use of these two equations, we will arrive at the refracted unit vector. Now you may ask why this is true. But this is true because the Snell's law goes in this way itself. u1 into sine of theta 1 is nothing but equal to mu2 multiplied by sine of theta 2. Now the sine of the angle between these two vector quantities is nothing but given as how much? The magnitude of the cross product between the a cap and n cap. That is nothing but your sine of theta itself. We are just using it in the vector form. Similarly, the sine of theta 2 is nothing but given as r cap cross n cap. Now in order to make this a vector equation, you just remove the magnitude signs. You just remove the magnitude on both the sides. You will be getting this vector equation called as equation number 1. Let's apply this and see whether this is true or not. Okay. So let us consider over here the situation where this is nothing but the x-axis, this is the y-axis, and this over here is nothing but the z-axis. And for z which is greater than or equal to 0, let the refractive index be equal to root of 2. And the refractive index for z less than or equal to 0, let it be equal to root of 3. The incident unit vector, let it be incident this way. Let's say that your I cap is nothing but given as equal to how much? Let it be given as 1 by root 3 in I plus 1 by root 3 in j and minus 1 by root 3 in k cap. This is the incident unit vector. We want to find out what is the refracted unit vector, right? So let's directly apply our Snell's law in the vector form. So you can write over here root 2 into a cross n cap. Now what is n cap? The n cap specifically points from the first media into the second media. You have to take only one direction of the n cap over here. It could be the other way also, but for convenience we are taking from the first media to the second media always. So n cap over here is nothing but equal to how much? It points in minus k cap. This is your n cap over here. That's it. Substituting the value 1 by root 3 I j k cross minus k cap is equal to, in the other media, root 3 times, we do not know this r cap, cross minus of k cap. That's all, our job is done. So therefore, if you divide over here, you get root 3. On simplifying, I cross k is minus j, so it is plus j over here. Is divided by 3 because root 3 becomes 3. J cross k is I, therefore this one is minus I. K cross k is 0. And on the other side, it is nothing but r cross k cap, r cross minus k cap. Can we write r cap as equal to rx in I cap, ry in j cap, rz in k cap? Definitely we can write it this way. And let's do the cross product of this with the minus k cap. Why? So that we are going to get two coefficients over here, the I and the j. So I cap cross k cap is nothing but minus j, therefore this one will be plus j cap. You'll have rx over here. Plus jk is nothing but I, therefore there will be minus I over here. K cross k is nothing but 0. On the other side, root 2 by 3 j minus I cap. So if you just compare, rx is nothing but equal to how much? Yes, compare the j cap coefficients, root 2 by 3. ry, if you compare the I cap coefficients, is also root 2 by 3. That's all. Now what you want to find out is rz value. But we already know that r cap is a unit vector which has a magnitude of 1, which means it is root of rx square. Square the rx over here, you get 2 by 9. Square of the ry over here, again it's 2 by 9. This rz is unknown to us, so square of the rz. That's all. So therefore you can write the rz square as equal to 1 minus 2 by 9 minus 2 by 9, which is 4 by 9. You get this as 5 by 9, which means your rz is plus or minus root of 5 by 3 itself. And now you just need to decide whether it's plus or minus for your r cap. So now rx is nothing but root 2 by 3. Correct, root 2 by 3 in I cap. And how much is the value of ry? That is also root 2 by 3 in j. And now rz plus or minus, right? So you notice how the vector is moving over here. It's moving in the negative z direction. The refracted light will also have in the negative k cap direction. So therefore it is not plus k cap. It must be minus root 5 by 3 in k cap. This is your answer, man. Snell's law in vector form, JEE advanced topic this one is, right? I hope you are satisfied with this one. ये ठीक है ना, कोई दिक्कत है?